Namaste. In this video, I am going to give the demonstration of flat top sampling and its reconstruction. So, to get any computer systems, in the computer systems, to get any signals, we need to convert analog signals into digital format. So, while converting digital signals, that is nothing but we are converting analog signal into a discrete signal. While converting analog into discrete, we are going to take the samples. The sample size, everything we need to decide, and we need to take the samples. So, sample size, after taking the samples, there will be a sample of signals, and we need to construct that using a sample signals. So, the sampled signals, what we are calling it as a quantized signals, or we are calling quantization. So, there if you give the continuity, that becomes a discrete signal. So, that discrete signal, how to get that discrete signal is using this flat top sampling. So, we will get the signal, and the amplified signal what we are getting at the end here will be a sampled signals. Sampled signals will be having a continuity. That's why we are calling this as a, and it is having a uniform amplitude. That's why we are calling it as a flat top sampling. And here the construction of the circuit is like this. Here we have used IC4052 IC. It is a 4:1 mux or 1:4 demux IC, and we have used 741 MUS741 IC. It is a op-amp IC. So how the construction goes means, see here you can see for one mode we are going to operate this. That is a 4:1 mux. So those two select lines will be there. So for one mode we are going to operate this. Here we have given for the input, we have taken one message signal that is of 200 Hz 5 volt peak to peak. That signal is passed through the pin number 5, and here you can see here we have connected one OA79. So it acts as a clamper circuit. So for that purpose we have used this OA79, and here in the pin number 10 you can see, so this is the carrier signal. We are going to give it for the mode of that mux IC, and here you can see we are going to give the square waveform. This square waveform we are going to give it directly to the pin number 10, but offset is not set here. For that purpose, while taking the signal from the signal generator, we are going to set the offset, and we are going to set the value of that voltage to the 5 volt level. So and then what we are going to do is taking the output pin of IC4052 from pin number 3, and from there we are going to give it to the pin number 3 of 741 IC. Before that, you can see here we have in the output side we have one microfarad capacitor, for the reason that why we have connected this 1 microfarad means it will hold the signal. So for a time being, so that hold signal is required, and we are going to give this signal to the voltage follower circuit, that is your MUS741 IC. So from the pin number 6 of the IC, we are going to take the output. That you can take it here also in pin number 3 also. You can observe the output, or you can observe the output at the pin number 6 also. So I will show. So I have done all the connections. Everything I have done here. I have connected everything. I have taken the fixed DC power supply of 12 volt that is required for my 741 IC, plus 12 and minus 12, and 5 volt supply is required for this 4052 IC. That is also we have given from this fixed power supply, and I have taken two signal generators. One is of message signal, and another one is for carrier signal, that is this square waveform. That is usually we should take 5 volt peak to peak, or in the range of 2 kilohertz. Here you can observe I have taken the message signal of sinusoidal waveform 283 Hz 200 range. That is I have taken around 200 to 300 range. That is here exactly at 283 now. Amplitude of 5 volt peak to peak. That is what the signal is here. You can observe the signal here, and also I have set the offset here for my carrier signal. That is I have kept the carrier signal as a square waveform, and I have given it to the pin number 10. So this one I have given pin number 10, and I have set the offset, and finally I will show the output. That is what I am going to get at pin number 6 of 741 IC. You can observe this is the input, and output you can observe. Yeah, this is the output of my circuit. That is flat top sampling output. What you can see here, see you can observe the output. So it is a sampled signal, and we got this sampled output here. You can observe here. So the output you can clearly, it is visible output. That's it here in the construction part. For reconstruction part, what changes we need to do is we need to change this pin number 6. We need to give it to the RC filter. So you can observe here we have R and C here. What I will do is I will change from here to, I will give the output to here, demodulated output here. You can observe that is just a simple RC filter. So I will change it. You can observe the output on the screen, on the CRO screen. You can observe. See, this is the output. This is the output. We can observe output is nothing but a reconstructed signal, that is nothing but a message signal what we have taken for the circuit. That is what we are getting at the end. That is what we are doing here actually is we using RC filter. It removes the higher frequency components, that is a square waveform, it removes, and we are getting a pure sinusoidal signal. You can observe the pure sinusoidal signal, and here we need to measure the frequency, we need to measure the amplitude. That's it. Thank you.